Hello everyone. In this video we're going to be simplifying a logarithmic expression. We have a to the power ln a divided by ln a, and we're going to simplify this expression. I'll be presenting 4 methods, and we'll start with the second one this time. So my second method basically involves substitution, and a lot of these methods are pretty much substitution. So I'm going to call ln a something. How about ln a equals x? Okay, now since ln means log with base e, by using the definition of logarithms, I can write this as a equals e to the power x. Again, I use the definition here. And now, if we ln both sides, we get ln of ln a equals ln x. Great. So let's go ahead and substitute these into our expression. We have a to the power ln a over ln a. And notice that ln a is equal to ln x. So we can write this as a to the power ln x over x. And now notice that a can be written as e to the power x. So let's go ahead and substitute that. So this gives us e to the power x to the power ln x over x. Now one thing that will be helpful here is bring the ln x inside as an exponent and leave the x outside, but x is going to be multiplied by 1 over x. So they're going to cancel out. And we end up with e to the power ln x, which is x. Awesome. So even though we got an answer in terms of x, we can always turn it into something in terms of a, because we know that x equals ln a. So our original expression then, a to the power ln a over ln a, just becomes x, which is ln a. Great. This will be the end of first method. Let's go ahead and, second method, sorry, because I started with the second method. Now let's go ahead and take a look at the first method. My first method again uses substitution, but it's a little different. Instead of calling ln a x, I'm going to call the whole thing something. So I'm going to set ln a over ln a equal to b. Okay, to b or not to b. From here, we're going to get, if you cross multiply, you're going to get ln a equals b times ln a. Now, b can be moved and it can be made an exponent, so it's going to become ln a equals ln a to the power b. Sweet. Now, we have ln's on both sides. We can kind of un-ln both sides, or we can do e to the power both sides, right? And that's going to give us the following. E to the power ln a equals e to the power ln a to the power b. And e to the power ln something is always going to be that thing. So from here, we're basically going to get ln a equals a to the power b. Awesome. Now, what does this give us, right? Well, ln a equals a to the power b, but what is our expression? Well, if you look at our expression carefully, we have a to the power ln a over ln a, and we call this b. Therefore, our expression is actually a to the power b, which is ln a. So that's going to be the answer. Just like with the second method, first method gave us the same answer, and of course it should, right? All right, let's go ahead and take a look at the third method. Now my third method is going to use the formula for change of base. And remember, we used this formula recently for a logarithmic equation, I think. So change of base works like this, and it works with any base. So suppose I have log n with base m. I can just write this in a different base, like let's say use x base x. So we can put the bases first, and then n is going to go here, it's going to be upstairs, and m is going to be downstairs. And obviously we can use any base, so I can also use ln. This is going to be ln n over ln m. Great. So now, how are we going to use the change of base here? We're going to use it backwards. So we have ln a over ln a. Now look at this expression and look at this expression. Aren't they the same? pretty much if ln a is equal to n, then a is equal to m, so on and so forth. So by using the change of base backwards, we can write this as, so let's go ahead and call this c, for example. It's going to be like ln c over ln a. And now I'm going to write this with base a. So this can be written as log c with base a. Notice that this is going to go here and this number is going to go here. Awesome. Now, what is the good thing about being able to write this with a base a is, remember, our original expression has base a, right? So the base is a here. That's why it's important to get a log with base a. All right, great. So now let's go ahead and substitute that. So we have a to the power ln a over ln a. Now I'm going to replace ln a over ln a with log c with base a. So it's going to be a to the power log c with base a. Okay, so it's going to be like this. Okay, great. And from properties of logarithms, and I think we can prove this very easily by using, setting this equal to something and then logging both sides, this is going to equal c. So when these bases are the same, you basically get this expression right here, whatever that is. Okay, great. So they are, in other words, they cancel out. Okay, so this is equal to say c, but what is c, right? We kind of have to go back and see what c is, and c is equal to ln a. Remember, we can back substitute from there. So c is equal to ln a, so our expression is equal to ln a as before. So now let's go ahead and take a look at the fourth method. All right, great. So now the fourth method, all right, so the fourth method is the following. So I have a to the power ln a. By the way, this problem is from a math Olympiad in Russia. I can't remember the book that I've seen it in, but I know it's an Olympiad problem. Or a math competition, whatever you want to call that. So now I'm going to focus on 1 over ln a, because 1 over log something can be converted to something else. So I'm going to write it like this. A to the power 1 over ln a. So I'm going to get that inside, and then everything else will be on the outside. And now I'm going to simplify what's inside the parentheses. So to simplify this, I'm going to use a basic property of logs. So if you have a log, xy and log yx, as long as they're defined, right? This is always 1. They're reciprocals. And you can easily prove this by using a change of base, because one of them is going to be ln y over ln x. The other one is going to be ln x over ln y. And this is why, as long as these are not 0. And obviously they can't be, right? They shouldn't be. Okay, great. So now from here we get this interesting identity that if you have 1 over log something, then it just switches the numbers around. So x and y kind of switch around, which means we can use that property here because ln is a log. So we have now a to the power 1 over ln a, and then that is going to be raised to a power ln a. Okay. Now, this can be written as a to the power 1 over log a with base e. And now that's going to give us, when you switch the e and the a around, this is going to be a to the power log e with base a. And then that's going to be raised to a power. And then now, notice that this is the same thing as e. So we get e to the power ln a. And as you know, it's equal to ln a. And this concludes the fourth method, and this brings us to the end of this video. There's a fifth method which uses something else maybe, but I'm not going to talk about it. Anyways, this brings us to the end of this video one more time. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.